I'm here with Synergen Met's Managing Director and CEO, Christopher Dunks, just here to have a brief overview of the company, what they're planning on doing in the renewable space, and also just addressing the recent IPO and discussion about investors and how they can get involved. Chris, how are you this morning?
Morning, Morgan. Great. Thanks for having me on.
Mate, if you wouldn't mind just giving a brief company overview and a bit of an industry overview as well about Synergen Met.
Sure. So Synergen is based in Brisbane. We've been around for 15 years developing technology in the clean tech space. So we've developed applications to make hydrogen by splitting methane. We've got an application that destroys this toxic chemical called PFAS. And we've recently purchased a group out of the United States, Phoenix Solutions. They've been around for 60 years, strong revenue and profitability, and we're rolling them into the business through this IPO process. So we're about 10 people here in Brizzy. We were about 15, 16 in Minneapolis, and we're looking to grow pretty hard and stepping through this IPO process right now. It's pretty exciting.
Then the IPO went live this week. Mate, would you be able to just kind of give a bit of an overview of what that means for investors?
So we're raising $20 million, coming into market with about 120 million market cap. Essentially, the 20 million that we're raising is going to be, the use of funds is going to be our first hydrogen project, which is with a group called Talau Energy based here in Brisbane as well. We've got multiple PFAS projects that we'll be developing. We have PFAS destruction sites that we're developing, one here in Wacol in Brisbane, one in Greenville in South Carolina, and then we've got other development activities around the business. So we've got a really structured use of funds. Basically, it means that the company will be generating revenue in the second half of the year from our PFAS applications and really gives us this footprint for growth.
Mate, I suppose the word PFAS has been thrown around a little bit lately. If you could just give us a bit of insight into what PFAS actually is and
Sure.
how your company is actually looking to remove PFAS from the environment.
No worries. So the PFAS that we're targeting is in liquids. So it's in water, it's in wastewater from waste dumps, it's in wastewater treatment plant water. And so essentially what we've created is two applications, one where we concentrate the PFAS in the water by creating a froth, flotation, and floating that froth. And then we take that concentrate and we put it through our plasma system, which exposes it to very high temperature, which breaks the bonds of the PFAS molecule. And we can then turn that into something which is less toxic, which is sodium fluoride or calcium fluoride. Sodium fluoride's in your toothpaste, and that can be managed by wastewater treatment plants. So we have these two applications. The market's quite significant. It's growing significantly. But the world's kind of waking up to the challenges of the PFAS molecule. You might see it in the newspapers. Forever Chemicals is what it's called. And there's probably press a couple of times a week, major press, certainly in the United States. Less here in Australia because we're a bit used to it now. But it's becoming very, very well known as an issue.
Yeah, look, it has been popping up here and there. And I suppose just giving people insight into what the actual structure is. What is PFAS?
PFAS is actually the name given to many, many different molecules. It's a hydrocarbon with a fluorine atom that's bonded to this carbon atom. It's the fluorine which is the issue, but it's the fluorine that actually gives it the properties that it has, which is why it's being used. It's a very powerful chemical, being used in many different ways. So what we do is we break that fluorine carbon bond, and that's a very strong bond, and it requires a high temperature. So we expose it in our plasma environment where the temperatures are high enough to break it, and then we recombine that fluorine with hydrogen. We make hydrogen fluoride, and then we scrub that and we make it sodium fluoride. So we kind of go through this multi-step process, making sure when that fluorine breaks, we rebond it with something else and it doesn't reform as something similar to what it originally was. So it's quite complex. We've got an amazing team of chemical engineers out of the University of Queensland. We've been working with the Australian Research Council for the last 3 or 4 years on this. But actually the ability for us to be able to do this application comes from the 10 years of work that we did in other areas, and it's all very directly applicable. So in reality, we've been running Synergen for about 15 years. A lot of that history all rolls into these applications that we have right now, and it all comes together. And so that's the PFAS molecule, and really you have to take an approach of how do you destroy it and not allow it to reform once you've destroyed it? And that's what we've done.
And look, I suppose you mentioned about the scrubbing of hydrogen fluoride. You scrub a portion of hydrogen. So in terms of the value add for the hydrogen production, how is that going to contribute to the current renewable energy market? And what do you estimate is the current addressable market for hydrogen production?
So our hydrogen application is separate from the PFAS. The hydrogen process that we have is a pyrolysis of methane. So we basically split methane using our plasma system in the absence of any oxygen, and we produce hydrogen gas and carbon black as a solid material which can be sold into the global market. The contribution we're making is really to those third-party companies that are looking to decarbonise. And if you look across the gas industry and the industrial industry, everyone is genuinely looking to decarbonise. We've been to a number of conferences recently where the investment that's going into decarbonisation of industry is awesome. It's amazing. It's really positive. These companies are identifying areas where they can do 3% reduction, 5% reduction. It's not like 30% reduction. It's all this incremental, but they're investing in all those areas. It's actually really exciting. So our contribution to that is being able to come along and provide an opportunity for natural gas or methane that might be used in an application to be converted into hydrogen. And so the emissions that come out of the hydrogen process are using hydrogen as a heating source. There's no carbon dioxide and there's no greenhouse gas emissions.
Right.
And when we make hydrogen, we make this carbon as well. And the way that we make the carbon, it's essentially a sequestration of the carbon. So we're not allowing any CO2 formation.
Okay.
So that's our contribution. We're really working alongside these industry partners. Addressable market, it's not really something that we look at necessarily and try to calculate. We know that there's a big market ahead of us. We know that from the interest that we're getting from industry, but we're really just taking our approach is each project at a time.
And it is a bit of an evolving beast within the renewable market and obviously the hydrogen market. It's having some time to get that significant uptake, but it is moving in the right direction.
It is, yeah. So the demand side is the question that's been asked for the last 12, 18 months as this space is hotted up. Where is the demand coming from? How are we going to address the demand? Where does the technology sit globally to be able to address that demand? What are the true and realistic forecasts for being able to produce hydrogen at volume? So they're slowly starting to be answered, those questions.
And I guess what's your point of difference when it comes to the PFAS breakdown? Because I know that that is being addressed overseas and some companies and governments are starting to really realise that PFAS is a toxic substance. We need to do something about it. Where are they in relation to your technology at this point?
So if we look at others that are dealing with the PFAS molecule, they concentrate it or they might even absorb it onto activated carbon, but then that goes into landfill. We're not aware of anybody else that can destroy and convert the PFAS molecule in the way that we have.
Okay.
So we see ourselves in a very unique space where we can offer this concentration process plus the destruction, whereas a number of our competitors on the concentration side, they concentrate it down to a product, but then they've got to put that in landfill. So there's an interesting conscience that's being generated as well with the customers that we're talking with. They don't want anything to go to landfill.
Sure.
It's a challenge with PFAS. If it goes into landfill, then 5 years, 10 years, 30 years, 50 years, whenever, it's going to leach. And so that PFAS is ultimately going to come out of that, of where it's been absorbed, and it'll start leaching, and then this whole cycle starts again.
It defeats the whole purpose, right?
It's infinite. Yeah, it's potentially like an infinite loop. So what we do is we destroy it and we get rid of it. And that's where there's a lot of attention, the applications that we have, because we're able to get this material and destroy it. So that's our true point of difference here. And I think it's very significant for us. We're really proud of the work that we've done. Amazing team. And so, we're rolling this out commercially right now.
Chris, I really appreciate you taking the time to give us a bit of an overview of the company and let us know about PFAS destruction. It's a really interesting space to be in. Really appreciate you taking the time to be here with us, Chris.
No worries, Morgan. Appreciate your time too. Thanks, mate.
To learn more about Synergen Met or to take up a position, please feel free to contact me directly by clicking the link in the description.